All right, here we go. Question number 3 from our 1316 homework number 2 in MyLab Math. They want us to graph the function, show at least 2 cycles, use the graph to determine the domain and range of the function. So since we're going to be graphing online where it says show at least 2 cycles, that's going to be kind of irrelevant because it's going to show the whole graph anyway. But let's get started looking at how we're going to get this thing graphed. First, we're going to copy down the equation. And since we have a sine or a cosine, specifically a cosine equation, what I'm going to do is I'm going to do a probably overkill. I'm going to show you my 6-step method for graphing a sinusoidal function. And a lot of the things are not going to apply because this is a basic problem, but I'm still going to list all 6 steps anyway. So step number 1 is to locate your starting point. And your starting point is determined by your trig function. So if we had sine, we would start at the origin. If we have cosine, we're going to start at the value of a, which in this case is -2. That is the coefficient of the trig function. So we know that our graph is going to start on the y-axis at -2. Second step. Once you know the starting point, then you need to take care of a phase shift if you have a phase shift, okay? But a phase shift requires that you have a constant added or subtracted to the x variable as part of the angle. And since we don't have that situation, we don't have a constant added or subtracted to the angle, then our phase shift is going to be, well, there's not one. So the way that I say that, I say if C is equal to 0, which that's understood to be 0, then there is no phase shift. So we're not going to have a phase shift this time. All right, step number 3, wavelength. And the wavelength is the period. For a sinusoidal function, the period is 2 pi over b, and b is the coefficient of x. So in this problem, the coefficient of x is 1, and so our period is going to be 2 pi over 1, which is 2 pi, and that's going to be our wavelength. Step number 4, you need 4 spaces. From start to finish, that's the way I remember step number 4, 4 spaces, 4 and 4. Step number 5, lay out your points. Y-O-U-R. Lay out your points. And step number 6 is connect the dots. All right, so let's get us a coordinate system here. And we're going to go through and explain how these 6 steps get us to our graph, okay? So step number 1, starting point, we have cosine, which is going to start at a, which is going to start at -2. So on the y-axis, our first dot is going to be down here at -2. That's step number 1, is starting point. Step number 2, phase shift, which remember we don't have a phase shift this time because C was 0. So then we can move to wavelength. Now the wavelength is the period, which in this case is 2 pi. So if I start on the y-axis, then I would end somewhere over here at 2 pi. Does that make sense? If I start on the y-axis, I'm starting at 0. And from 0 to 2 pi is a distance of 2 pi. So that would be my wavelength. And you always finish where you start. So if I start at -2, I'm going to finish at -2. That'll make one complete cycle, 1 wavelength. Okay, now that we have the period, the wavelength, now we're going to need 4 equal spaces. From start to finish, I've got 1 big space. I need to cut that in half, and then half the halves. And so now I have 1, 2, 3, 4 spaces from start to finish. Now I can lay out my points. Now remember, this function is sinusoidal. That means it's going to make a wave. So if I'm starting at -2, at the first hash mark, I'm going to get to the x-axis. And then at the next hash mark, I'm going to be up at +2. Now that's as high as this wave can go. So at the next hash mark, I'm going to have to head back down to the x-axis. And then at the next hash mark, we'll be at -2 again. Okay, so remember, sinusoidal means that these functions are going to make a wave. And if you notice, the reason that I need the 4 spaces is because the hash marks are where your points go. And now we can connect the dots, okay? Step number 6, connect the dots. Making a wave, just like so. Now, if I needed another period, I could just stretch this line out all the way over here to 4 pi, because 2 pi and 2 pi is 4 pi. That'll make another wavelength. Cut those in half, and then I just continue the pattern. Up, up, down, down. And I make another wave, okay? So that's how we're going to graph that manually. Now we're going to graph it electronically. So I'm going to click to enlarge the graph. And you're going to see in our graphing tool over here that you have a sine tool and a cosine tool. So we're going to click the cosine tool and then click on the graph, and it's going to pop up this, I guess we could call this the toolbar, where you're going to have to input the amplitude. And what was our amplitude? 2. Remember, the amplitude is the absolute value of the number in front. So our amplitude is going to be 2. Let's change the amplitude to 2. The period was 2 pi. There was no vertical shift, okay? So I'm not going to change that. I'm going to leave that to 0. We did not have a phase shift, okay? So we're going to leave the phase shift at 0. And reflection about the x-axis, okay? So when that amplitude is -2, that means that your wave really should begin at -2 on the y-axis. Let me scroll down. Remember when we did this by hand? On the y-axis, the graph should start at -2. And if you look over here right now, it's starting at +2. So that means that I need to select, whoops, I lost my toolbar. Here, amplitude is 2. And we need to select reflect about the x-axis. And I've totally screwed this up. Yeah, so let's hit clear. Sometimes you make a mistake. You got to clear and start over. All right, so here we go, starting over. We have a cosine. Amplitude is 2. Period's 2 pi. No vertical shift, no phase shift. But again, remember that it's going to start at +2. So we're going to have to click this button that says reflect about the x-axis. And that's going to make it flip over and start at -2. Okay, so then this now looks like what we drew over here, okay? And we're going to save that. And before I actually click to check that, I'm going to show you one more thing, and that's going to be Desmos. So if I bring down this window here, we're actually going to go to Desmos, Graphing Calculator, and I'm going to try to show you that we can actually type in this equation that we were given, y equals negative 2 cos. You can type in cosine x. And if you notice what that does, it draws the graph for you over here, okay? So here, whoops, I'm sorry, negative 2. Boy, you got to watch me close. Negative 2 cosine x. Notice that that does give us starting on the y-axis at negative 2. And if you click on this point over here, you can see that it ends at 2 pi. So from 0 to 2 pi, that is our wavelength. And then this is one complete cycle. And then if I click and drag this over, you can see again that I didn't lie to you. This next cycle would be at 4 pi, just like we labeled it over here in the hand-drawn graph. Okay, so the Desmos online graphing calculator is going to be a handy tool for you to use and check what you do manually, okay? Or if you're not sure how to start it, you can look at it here and maybe get an idea how to start that. All right, so I hope all that was helpful. Let's see now if I'm right, okay? Check. And then don't forget that it wants us to also determine the domain and range. Now, the domain of a sinusoidal function is all real numbers. And that's because this wave will continue to go infinitely far in both directions, left and right. So we're going to input in interval notation, negative infinity to infinity. That's the way you say all real numbers in interval notation. And the range is how low the graph goes to how high it goes. So notice that this wave is going to bounce back and forth between negative 2 and 2, and it's never going to go lower than negative 2, and it's never going to go higher than 2. But it does touch at those points. So instead of parentheses, we're going to use brackets. Brackets because it touches at negative 2 and at 2. And so that's the way the range should look. Remember, the range are the y's from low to high. Bam. Man, I hope all that was helpful. If you have any questions or comments about any part of this process, please leave those in the comment section below, or you can text me. And thanks for watching.